This question asks us what reaction rate means, and then we have to use the given graph to work out the mass of aluminium remaining after 5 minutes has passed. The rate of a reaction is a measure of how the quantity of either a reactant or a product changes over time. The numerator can be the change in mass or concentration or moles or volume. For example, if it's the rate in terms of volume change over time, it would be the final volume minus the initial volume over the final time minus the initial time. For the given reaction, where a piece of aluminium is placed into excess hydrochloric acid, hydrogen gas is produced, and the volume of the gas can be measured over time and plotted on a graph. Initially, the volume of gas produced increases rapidly, as we can see from the steep gradient. Then its rate of production begins to slow down, and eventually it is no longer produced when the reaction is over. The gradient of the graph at any point in time tells us the rate at that point in time, but we can take the gradient using 2 points on the graph if we want to find the average rate over a certain period of time. We are told that the average rate for the first 5 minutes is 0.033 decimeters cubed per minute. And we need to determine the mass of aluminium left at 5 minutes. How can we do this? Well, since we know the rate and the corresponding time period, we can calculate the volume of hydrogen gas produced, which is handy as there are no values for the volume of hydrogen on the y-axis of the graph. We can then use this volume and divide it by the given molar gas volume to calculate the moles of hydrogen gas produced under these conditions. Then, using the balanced equation, we can work from the moles of hydrogen to a moles of aluminium. And then we can determine the mass of aluminium, since we can work out its molar mass. So let's do that. We can take the rate equation, put in the given average rate for the first 5 minutes, and the change in time, and we can calculate a volume of hydrogen produced in 5 minutes, which is 0.165 decimeters cubed. Taking this value and dividing by the given molar volume, which is the volume occupied by 1 mole of a gas at a specific temperature and pressure, we get 6.74 times 10 to the minus 3 moles of hydrogen produced at 5 minutes. Now, since 2 moles of aluminium produces 3 moles of hydrogen, according to the stoichiometry in the balanced equation, we can work out the corresponding moles of aluminium that would be used up to produce the moles of hydrogen we just calculated. We have not shown how to do this calculation here, but one way is to cross-multiply and solve for x. Solving for x, we get 4.49 times 10 to the minus 3 moles of aluminium reacted or used up in 5 minutes. We can then convert the moles of aluminium reacted to a mass by multiplying the moles by its molar mass. We get 0.12 grams of aluminium used up in 5 minutes. But the question wants the mass of unreacted or remaining aluminium at 5 minutes. This is calculated by taking the starting mass minus the mass which was used up in the reaction. The starting mass was given to us. It is 0.5 grams. So taking 0.5 grams minus the 0.12 grams used up, we get 0.38 grams of aluminium remaining. Next, we need to explain why the rate changes in the first 5 minutes and isn't a constant value. Well, as time passes, so more aluminium is used up, and its mass and surface area decrease. This means fewer aluminium atoms are exposed to acid molecules in solution. And so there are fewer effective collisions per second. And so the rate slows down.